Okay, so today we're going to start looking at trig for the first time. Sohcahtoa Day. You've heard probably somebody say to you before Sohcahtoa. Or if you haven't, just talk to anybody who's been through Mountain High School in the last 30 years. You say Sohcahtoa to them, they'll know what you're talking about. Okay? This is a way that we're going to learn about our trig ratios. And today it's mainly just learning about what the ratios are and identifying them and identifying parts. Again, this is not going to be super difficult, but it's going to rely a lot on slowing yourself down and identifying parts of the triangle so you know what you're working with. But first, before we can even do this and start getting into the definitions more deeply of Sohcahtoa that are there, we have to understand what side is what with a triangle. Because the names of my right triangle are going to have sides. I just said that backwards. The sides of my right triangles are going to have names. So the names are going to have sides. Well, I guess kind of. But we all know what the hypotenuse of the triangle is. And of course, we have the hypotenuse here. Any of you read Sandra Boynton's books when you were little kids? Have the little board books. She had all sorts of little books. If you would do that, you would recognize the drawings. They're very classic young children's literature. She does a lot of stuff. But she does math cartoons too, which is kind of funny. So anyway, when we have a triangle, there are three sides that we're going to deal with. We're going to deal with the hypotenuse, the opposite side, and the adjacent side. Now, the hypotenuse is always the hypotenuse. We already know how to find the hypotenuse. It's clearly the side across from the right angle. It's the longest side of the right triangle. That's the hypotenuse. The opposite and adjacent are relative terms. And to demonstrate this very simply, just sitting in your seat right now, because all of you are kind of facing different directions, I just want you to, without poking your neighbor, to point to the right. Point to the right. Okay? And we're pointing all different directions, aren't we? Why is that? Why are we all pointing different directions? Shouldn't right be the same for everybody? Isn't right the same for everybody? Yes. But yet I'm pointing to this wall over here, and right is pointing to the front of the room, and you're pointing to the back of the room. Okay, and some of you are pointing to that wall over there. Why are we not all pointing in the same direction? Some of us are wrong. Okay, yeah. Are they wrong? Yeah. Or, in this case, is the direction right relative to our point of view? Okay? See, just because someone has a different answer from you doesn't make it wrong. They just may have a different point of view. And in this case, the idea of being to the right of something, or to the left, whatever, is relative to point of view. And that's the way opposite and adjacent are going to work when naming sides of a triangle. They're going to be relative to point of view. Now, let's all point up. We're all pointing in the same direction, aren't we? Okay, well, they'd be pointing in the same direction if they were there. Well, yeah, we'll ignore that idea. Okay, so we're all pointing in the same direction. Why? Because up is an absolute reference. Okay, it doesn't matter which way I'm facing. I mean, if I was standing on my head, this would still be up, because up is defined by gravity for us. Okay, so that's up. And that's like hypotenuse. The hypotenuse is absolute. It doesn't matter where you're at. The hypotenuse is always going to be the same. Opposite and adjacent are going to be relative to point of view. And our point of view is going to be one of my two acute angles. So, we already did that now. So when we look at this, my point of view, like I said, it has to be one of the two acute angles of the triangle. My point of view will not ever be the right angle. And one thing I suggest is when you're working with these triangles, just draw a little stick figure at your point of view. That's where the person is standing. If the person is standing right here at angle A, which side is going to be the opposite for angle A? B is not a side. CB, okay? CB is going to be the opposite side. The hypotenuse is clearly AB because it's always AB. That's the right angle. That's the longest side. So the adjacent side has to be over here, CA. But if my point of view switches to over here, now CA, which was the adjacent before, now CA is the opposite, isn't it? And CB, which was the opposite, becomes the adjacent. So the terms opposite and adjacent side are going to be dependent on an angle, a point of view. It doesn't make sense to say which is the opposite side in this triangle. It's which side is opposite of this angle in the triangle. So we have to define a point of view for opposite and adjacent, and therefore for any of our trig functions, sine, cosine, or tangent, to make any sense. So we always have to define a point of view, and like I said, that point of view is always going to be one of my two acute angles. Now, can we do a point of view from the right angle? Yes, we can. But that is not a topic for geometry. That's a topic more for trigonometry or pre-calculus. So we're not going to worry about that. We're always going to keep it simple because this is an introduction to trigonometry. We're going to keep our point of view at one of the two acute angles in the triangle. All right, so sine, cosine, and tangent. Let's go back to our first page. Here's where we want to get this down now. Here's where we want to get this down. The sine ratio, which, by the way, is on your calculator, it's a SIN button. That doesn't mean sin, it means sine. It's just an abbreviation, so you don't get to push your button that says SIN and go, I'm sinning, because I have somebody who does that almost every year. This button makes me sin. No. It's an abbreviation for sine. S-I-N-E is the word. What does sine mean? Sine is just the name of the ratio, okay? The ratio has been given a name, okay? The sine ratio is the ratio of the length of the opposite side over the hypotenuse. You can put that in your notes. That's there. Sine is opposite over hypotenuse, and that's what SO stands for, sine opposite hypotenuse. C is for the cosine ratio. The cosine ratio is the adjacent over the hypotenuse. Okay? And that's Ka, C-A-H, so Ka, A-H. Important when you say Sohcahtoa that you say it correctly, because if you say it incorrectly, you will not have the right letters down and you'll get the wrong ratios. And tangent is opposite over adjacent. That's our third ratio, is the tangent ratio. And it's the ratio of the opposite length, the opposite over the length of the adjacent. So we get Sohcahtoa. That's where Sohcahtoa comes from. That's what helps us remember what our three ratios are. That's why when you get quizzes and tests and stuff like that, if you don't always have it written down, I really just recommend that on the top of your quiz and test, you just write Sohcahtoa. Okay? Write that up there, and then you just look and say, oh, a sine. Wait a minute, which one do I need for sine? Oh, it's S-O-H, opposite over hypotenuse. Okay, there it is. Boom. I don't have to have it all memorized. Just that one little phrase gives me everything I need. Okay? So with that said, interesting little Pythagorean triple here, 18, 80, 82. 18 squared plus 80 squared equals 82 squared. Didn't know that one, did you? It's a fun one. Okay, let's find the sine, cosine, and tangent of f. So the way we're going to express this now, notice this is going to be sine of f. So this tells me right there, the s right here tells me which angle is my perspective. Where am I standing? I'm standing here at angle s. Okay? So what I like to do, especially when I'm first starting out with problems like this, is what I actually want to do is draw my little stick figure there, and then label the sides. Which side? I start with the hypotenuse. Should be obvious which side is the hypotenuse here because it's the longest side. Which one is it? By length, by number. 82 is my hypotenuse. Which side is the opposite for this angle? Now, some people have difficulty with this idea of opposite. So the easiest way, and what some people do, is literally to draw a little dashed line through the middle of the angle, and the first side you hit, that's your opposite side, isn't it? That's how we find an opposite. So the opposite side here is 80. And if I have the hypotenuse and the opposite, then this must be the adjacent. Now, some people say, well, adjacent, isn't a hypotenuse also adjacent to the angle? Yeah, but it's the hypotenuse, so it can't be the adjacent. But for the sake of simplicity, it's usually easiest to identify the hypotenuse and the opposite first, and then the third side must be the adjacent side. That's what I recommend. Identify that opposite side, the hypotenuse, and that third side has to be adjacent. The hypotenuse cannot be the adjacent side. It's the hypotenuse. Each side gets only one name. That's where that whole working for the 90-degree angle thing gets really confusing, because then the hypotenuse and the opposite are the same side, which is just throws everything off. So what would the sine of S be? So there you go.
Harry Potter and the Poms team.
Woohoo!
Thank you.
No Potterheads in here? No? All right. So if this is so sine of S is the opposite of the hypotenuse. So sine of S would be what? How long is the opposite? 80. How long is the hypotenuse? 82. And I just reduce that. Done. That's it. How about the cosine of S? Cosine is adjacent over hypotenuse. So how long is the adjacent side for angle S? How long is the hypotenuse? If I reduce that, that becomes 9 over 41. And the tangent is the opposite over adjacent. How long is the opposite? Over, so 40 over 9. That's all it takes to find the sine, cosine, and tangent of that. Congratulations, you're doing some trig. Are we announcing again? Maybe not. Okay, so now what if we switch to angle R?
Alright, correction everybody. My apologies, correction. Link crew, Harry Potter, Poms, not yet. 845, forensics, National French Honor Society, and French Club.
All right.
Correction, not Link crew, Harry Potter, Poms, who are at 945. 845 is forensics, National French Honor Society.
All right, this is going to be fun in the podcast. Woo! All right, preserve forever, her announcements. All right, way to go, Brechtel. Now if I switch my perspective to angle R, which side is the hypotenuse? It hasn't changed, right? Because that's absolute. Now which side is the opposite? The 18. And now, so this becomes the adjacent. Okay? So the sine of R, if we switch our perspective to R, is what? Sine is opposite over hypotenuse. So 18 over 82, which is 9 over 41. Cosine of R is adjacent over hypotenuse, which would be 80 over 82, yeah. So that's 40 over 41. And the tangent of R is opposite over adjacent, Toa, 18 over 80, which would be 9 over 40 when I reduce it. Okay? And yeah, you are expected to reduce fractions. So that's how we find sine, cosine, and tangent ratio values for an angle. It's not super hard. The key is making sure you identify your perspective so you know which side is which. And really, when you're just starting out here, it really is important that you label the sides of the triangles so you know what it is you're looking for. If you just are trying to do it by memory, you're going to mess them up. Label what's what, write Sohcahtoa across the top, make sure you're doing that. Soon enough, after doing this for a few days, you're going to be like, oh yeah, I know sine is opposite over hypotenuse, boom, done. You'll catch it much more quickly. But here, when we're just starting out, you want to go slow. You want to take your time. You don't want to rush it. And here's a similar triangle. Okay? So how do I know it's similar? Because I divided the length of each side by 2. So if I set up a ratio, there'd be 2-to-1 ratio. We've done the similar triangles thing. What do we notice? The sine of S. So I put my perspective here. This is my hypotenuse. Which side is my opposite? TR. And so this is my adjacent. So sine of S, notice I'm not just saying sine equals, it's sine of an angle, because again, without that perspective, the terms opposite, adjacent mean nothing to me. So I can't just say sine equals, it's sine of this angle equals. Sine of S equals what? Sine is what ratio? Opposite over hypotenuse. Which side have we labeled the opposite? 40. And hypotenuse is 41. It really is that easy. I think some of you are hesitating because you think you're missing something. You're not. Cosine is the ratio of which two sides? Adjacent is, and hypotenuse is. These don't reduce. And tangent is opposite over adjacent, Toa. So that's 40 over 9. If I switch my perspective to angle R, still the hypotenuse. Which side is the opposite now? 9, which means this must be the adjacent. And again, adjacent makes sense because it's right next to the angle that we're talking about, but it's not the hypotenuse. Okay, so the sine of R now is opposite over hypotenuse, which is 9 over 41. Cosine would be adjacent over hypotenuse, which is 40 over 41. And tangent is what ratio? Okay, what's the sides? Opposite over adjacent, 9 over 40. There we go. Now, wait a minute. Those are the exact same values we came up with here, even though it's a different size triangle. Why? Yeah, because the triangles are similar. We know the sides are different, but what's congruent? What parts of similar triangles are congruent? The angles, yeah. So the angles didn't change. So the size of the triangle doesn't matter. It's the size of the angles that matters when setting these up, because for any similar triangle, the sine, cosine, and tangent are going to be the same. Basically what trigonometry does, we had our 30, 60, 90 and our 45, 45, 90 triangle, right? And we had 2 patterns that we learned for those 2 triangles. But that only solved 2 triangles for us, easily. What Trig does is it standardizes the ratios of sides for all right triangles. So if this angle is 78 degrees, the ratio of opposite over hypotenuse, the sine of that angle, S, is the same for every triangle that has a 78-degree angle. It's a constant. That's what Trig does for us. It gives us tables of values and information about every possible right triangle. And it allows us to now, in order to solve a right triangle, and to solve a triangle means to find all the sides and all the angles of the triangle. In the past, we've been able to find sides using things like Pythagorean theorem or, altitudes to right sides, right angles and stuff like that. But now we're going to be able to solve pretty much any right triangle if we know just some very minimal information. In fact, one side and one angle other than the right angle, and we'll be able to figure out everything about that triangle. So Trig gives us a lot of power to do things. And we're going to spend time solving those things out the next few days. Today we're just setting up ratios. Okay? Now, again, they aren't always super nice numbers like that. Sometimes we get sides that have square roots. That's okay. We're going to deal with that. This time we want to give the ratio, and then you want to pull out your calculator. Use your calculator to find a decimal value, round the value to the nearest 10,000. Now wait a minute, let's think about this. 10,000, how many decimal places is that? So if I have x point n, so here's my decimal point. What's this first place? Tenth, then hundredth, thousandth, 10,000. So we're going to go to the 4 decimal places, aren't we? So we're going to look at this 5th decimal place when we're doing this and round up if that's a 5 or above and round down if it's a 4 or below, right? Or leave it as is if it's down or 4 or below. So you have to look at that 5th decimal place. That's when it's going to make a difference. If I wind up with an exact value like 1.5 and I want to nearest 10,000, I'd report it as 1.5000. I'd still do 4 decimal places, even if the last 3 are zeros. Okay? So, because some people have had difficulty with some rounding. I want to make sure we're all good with that. I know we learned that a long time ago, but that's okay. So let's take a look at this one. I want to find the sine of Q. Okay? Sine of Q. If I'm doing just this problem, what's my first thing? It tells me an angle, so that tells me a point of view. And by the way, we can assume that angles that appear to be the right angles are the right angles in these pictures. They aren't always marked, but the right angles should be fairly obvious. Okay? So sine of Q. Q is my perspective. I'll make my Q the head of my little stick guy. Very exciting. Okay, he's sticking his tongue out at you. Kind of a sassy stick person. All right, so let's identify our sides. Which side's the hypotenuse? Okay, there's my hypotenuse. Which side's going to be my opposite? And this is going to be the adjacent. And my opposite and adjacent happen to be the same, which is fine. Oh, what kind of triangle is this? 90-45. It's a 45-45-90, isn't it? Or pattern, 8-8-8 root 2. Oh, so I know the angles are going to be 45s. Yay! But that doesn't tell me the sine and cosine. So what's the sine of Q? Sine is opposite, which is 8 over 8 root 2, and the 8s are going to cancel. So it's 1 over the square root of 2. And now we want to rationalize that. So we multiply root 2 over root 2, and I get root 2 over just 2. But for your calculator, decimal approximation, you could just plug in 1 divided by the square root of 2. Your calculator doesn't care if you have square root in the denominator. Okay? What would that be decimally? 0.7071. Okay, 0.707 what? 1. Okay? That's the sine of that angle. So since now I know that's a 45-45-90, I know the sine value for any 45-degree angle is going to be 0.7071. That's the ratio of the opposite over the hypotenuse for any 45-degree angle in a right triangle. How about the tangent of W? Ooh, I'm going to switch my perspective. My hypotenuse isn't going to change. I can leave that. We're going to switch down here to W. Now, my opposite is QR, and this is my adjacent. What is my tangent going to be? Tangent is what ratio? Toa. So OA, opposite over adjacent. 8 over 8, which is 1. Cool. Okay. How about this triangle, 5, 12, 13? Is that one of our special right triangles? Is that like a 30, 60, 90? No. Can I assume that this is a 30-degree angle or anything like that? No. I don't know what the angles are. We will actually find a way to figure out the angles next week, okay? I'll show you how we can actually figure out exactly what that angle is. But right now, we're not going to worry about that. We're just going to call it angle L. So angle L is my perspective. Which side is my hypotenuse? 13. Which side is my opposite for this angle? And for this angle, this must be the adjacent. So the cosine of L would be what? Okay, cosine is adjacent over hypotenuse, so 12 over 13. And my tangent would be? I think it's Caritas, but obviously not part of the Spanish club if they're saying Caritas. All right. So what would the tangent of L be? Tangent is Toa. 5 over 12. Okay. How about as a decimal value? 1 obviously would be 1.000. 0. Okay. 12 over 13, what is that? 0.9230. So 0.9231. Okay. How about the tangent? 0.4137. Okay. You can put the 0 point if you want, or you can just do the decimal point. It's fine. Why am I having you do these 4 decimal point things? Why? What's the point of that? It is standard to round trig values to 4 decimal points. That is a standard that's used with trig to 4 decimal places, to the 10,000th. And again, the reason why is going to become more clear as we do more with trig. Right now, we're just working on identifying what is the sine, cosine, tangent ratio for a side and switching that to a decimal, which is just plugging numbers in your calculator. All right. So if 2 triangles are similar, and a summary here, then they have the blank values for sine, cosine, and tangent ratios. Same, yes. So if I had a triangle similar to this triangle, let's say every side was 3 sizes long, 3 to 1. So it was 39 and 36 and 15. And I did the sine of L, that'd be 15 over 39, but guess what? I just multiplied every side by 3. That 3 would reduce out, and I'd still wind up with 12 over 13. Or 5 over 13, sorry. Cosine would be 12 over 36 over 39, which should still reduce to 12 over 13, or the exact same decimal value. So for similar triangles, the values have the same, they get exactly the same values. This would imply for any given angle measure n that the value of sine of n is a constant. Okay? So for any given angle measurement, the value of sine n, and for cosine and tangent too, but we'll just use sine as a general, is a constant. There is a specific value for the sine of any angle, and the cosine of any given angle, and the tangent of any given angle, because the ratio of the sides is always going to be the same, if that's the acute angle. All right, so that endeth the lesson for today. Let me stop this, and I'll get you your worksheet that we're going to be working on today, which is going to be identifying just what we did. It's going to be things just like this. So, go here.